Now we're dealing with Hamiltonian circuits. Hamiltonian paths and circuits is a lot like Euler circuits, except we're using a different piece of the graph that we have to get to exactly once. A Hamiltonian path uses each vertex exactly once. Use each vertex exactly once. A Hamiltonian circuit is a Hamiltonian path that begins and ends at the same vertex. And you're given a diagram like this where it has different cities on each vertex, and the path between each city is the airline route from city to city, and it tells you to plan a trip around the world, being able to visit each city exactly once and get home. So wherever you start with is considered where you live, is considered home, and then being able to get back home means you've created a circuit and you want to visit each city exactly once, get back home. And so what they have to do is they have to now understand edges in this case are essentially irrelevant. Now, you have to use the edges to go from vertex to vertex, but you don't have to use every edge. And so they'll take their knowledge of Euler circuits and they'll start to try to justify why they go a certain path because they're trying to use all the edges. And they need to understand you don't have to use all the edges. All you have to do is use all the vertices, all the dots on this graph.
So when we start looking to write a conjecture that could determine if a graph is a Hamiltonian circuit, we look at the same four graphs whenever we were trying to determine the conjecture for Euler circuits. This first graph, notice if we start in the upper left vertex, we can go all the way around the graph, visit each vertex exactly once, and end at that same vertex. This is a Hamiltonian circuit. When we look at the next graph, no matter how we go around this graph, we cannot end and begin at the same vertex without missing a vertex or without going to a vertex more than once. We can, however, go to each vertex exactly once. We just can't begin and end at the same spot. This is a Hamiltonian path. Taking a look at this third graph is identical almost to that second graph. That edge that goes around the square portion really doesn't do anything. This is still just a Hamiltonian path. You can get to every vertex once, but you cannot get back to where you started. Looking at the fourth graph, if you notice this little M shape that I'm taking, starting at the middle, going up to the right, down, left, up, and back to the middle, that is a Hamiltonian circuit. You'll notice I didn't use every single edge. And then trying to make a conjecture between the two that are Hamiltonian circuits, you'll pretty much see there's no real similarity, so there is actually no conjecture. There's no one conjecture that will determine if a graph is a Hamiltonian circuit. You'll see several Hamiltonian circuits that look like polygons, that have some kind of consistency. That's one polygon inside of another polygon, and they're connected in multiple places from one to the other. However, there's nothing that you can look at a graph and say it is a Hamiltonian circuit. You just have to attempt it. And that is Hamiltonian circuits.